Okay, so the next thing we're going to look at is we can also use the Big M method to do minimization problems. And to do this, what we do is we're going to minimize basically the opposite of whatever you have. So if you've got minimize, c equals a 4x1 plus a, I don't know, 3x2, what we're going to do is we're going to maximize the opposite. So we're going to maximize p is equal to the negative min of c equals negative 4x1 minus 3x2. So we're going to kind of subtract those off. And so that's how it's going to work. So what I want to do is, there wasn't a lot of good examples. And so what I'm going to do is I'm going to say, well, let's change the problem here. It used to say maximize. Let's call it minimize this. And these are the constraints, okay? So with that, what do we need to do? Well, we need to say, okay, well, let's instead of minimize, we're going to say, well, it's going to be maximize. P equals going to be a negative min of C. And this is supposed to be a C max, because when we do minimize, it's going to be C. And that becomes now a negative 4x1 minus 3x2. Okay. And it's going to be still subject to, and so we're going to have x1 plus 3x2 less than or equal to 24, and x1 plus x2 equals 12, and x1 and x2 are going to be greater than or equal to 0. So we've converted the minimization problem into this maximization by changing the objective to the opposite, basically. Okay, so now let's convert the inequalities to equalities and add in our slack variables, our artificial variables, surplus variables, whatever we need to do to make this problem work. All right, so first things first, um, what is going to be our P? So it's going to be, we're going to maximize P equals negative 4x1 minus 3x2, and we'll leave some space here in case we have artificial variables that we add in. Then we're going to have subject to what? Well, we're going to be subject to what? x1 plus 3x2. Now, this is less than or equal to, so we're going to add a slack variable 1, and that's going to be equal to 24. Now, since this is equal to, that means we're going to add the artificial variable. So we'll have x1 plus x2 plus a1 equals 12. Now, since we added it here, we're going to have to subtract off ma1. Okay, so that's not a problem. And x1, x2, s1, a1 are all going to be greater than or equal to 0. Okay, so our problem up here is actually going to be a 4x1 plus 3x2 plus ma1 plus p equals 0. So when we put that into Tableau, that'll be kind of our units here. So our preliminary Tableau is going to be what? Well, we're going to have x1, x2, then we have s1, then we have a1, then we have a p. And again, we're not going to put anything over here because we don't know what we have. We know we have an A1, it's going to have M in it. So we're going to have to do some row operations before we actually put our variables there. So this is going to be what? 1, 3, 1, 0, 0, 24. This is going to be a 1, a 1, a 0, a 1, a 0, and a 12. And this is going to be a 4, a 3, a 0, an M, and a 1, and a 0. And we need to eliminate this. Okay, so how do we do that? Well, it looks like if we take minus M times row 2 plus row 3 and add it to row 3, and that's going to be our new row 3. That should get us what we need here. So when we do that, that gives us what? Well, we'll have now x1, x2, s1, a1, p, and we'll have, this is going to be what? A 1, a 3, a 1, a 0, a 0. Then we had 24. And then the same with the next row. So it's going to be a 1, 1, a 0, a 1, a 0. And that was a 12. Now we have minus m plus that. So it's going to be a minus m plus 4. It's going to be a minus m plus 3. That's going to be a 0. It's going to be a 0. That's going to be a 1. And that's going to be what? A minus 12m. Okay. So now, what do we have? Uh, this one is, remember, m is a positive, so that's a bigger negative. If we add 4, that's going to be a smaller negative than this one. So this one actually is going to be the most negative because if we have a higher negative, add a smaller number to it, it's going to be more negative still. So that's going to be where we have. So now we have to take what? Or for a quotient, we have to take 24 divided by 3, which is 8. And here we have 12 divided by 1, which is 12. So that one's the smallest. And so if we circle our pivot point, that's going to be this one. And so we go, okay, that's going to be then what? That's going to be S1. That's going to be A1. That's going to be a P. And so this is going to enter, and this one's going to exit. And so how do we do that? Let's say we take 1/3 row 1, and that's going to be our new row 1. And then we're going to take a -1/3 row 1 plus row 2, and that's our new row 2. And it looks like if we take a 1/3 m, that's going to probably disappear. And then -1 and times row 1, and then we add that to row what, 3. That's going to go to row 3. So that's going to be minus 1m plus m. Then we have that's going to be that. So yeah, so that should work. Okay. All right. So now what do we have? So now it's going to be what? X2 A1 P. This is X1, X2, S1, A1, P. And so we're going to take 1/3 of that row. So it's going to be a 1/3. That's going to be a 1. It's going to be a 1/3, a 0, a 0, and an 8. Now, if we really want to, we can, since we've already taken 1/3 of that, we can say, okay, well, if we take a negative of this plus this, that's going to be what? That's going to be a positive 2/3. That's going to be a 0. That's going to be a negative 1/3. That's going to be a 1. That's going to be a 0. And that's going to be 12 minus 8. So that's going to be a 4. Okay. And when we add that, so that's going to be a third of that minus that. So it's going to be a minus 2/3 m. And then it's going to be plus 3. And then this one's going to be 0. And this is going to be a 1/3 m minus 1. This is going to be a 0. That's going to be a 1. And so that's going to be 8, so it's going to be a minus 4m. And then it's going to be 8 minus 8, minus 24. Okay. So we're getting some weird fractions and stuff in here, but that's okay. So now which one's negative? Well, that only is a positive. So this is the only one that's negative. And so now what we have to do for our quotient, if I can write it, is going to be 8 divided by 1/3. So that's going to be multiplied. So that's going to be 24. And this is going to be it's a 4. It doesn't work right, but a 4 divided by 2/3. So that's going to be what? 12 by 2, so that's going to be 6. So that's going to be the smallest. And so if we make this one, that's going to be where our pivot is. Now, do I want to do them all at one time again? Well, I suppose I can. So that's going to be what? We're going to have to take 3/2 row 2. So that's going to be the new row 2. If I take a minus 1/2 row 2, 2 plus row 1, that's going to be a new row 1. And so then this one I'm going to have to take, so this is negative 2/3. So I'm going to have to take just a m and then minus, and then I need to get that to be, so it's a minus what, 9/2. And that's a row 2 plus row 3 goes to row 3. Now, do I think I can fit the next one on that page or not? We can try. So this is going to enter, this one's going to exit. And so now we're going to have x2, x1, p. This is going to be x1, x2, s1, a1, p. And so if we multiply that one by 3/2, we're going to get a 1. Let's see. What did I do here? Um, that's going to be 0. And then that's going to be a 3/2. So that's going to be a -1/2. That's going to be a 3/2. It's going to be a 0. And that's going to be what? A 6. Then that plus that, that's going to be a 0. And that plus that's going to be 1. That plus that's going to be half. That's going to be a what? -1/2. It's going to be 0. That's going to be 2, 6. That's going to be 6. And then this one's going to be what? That better be 0. That's better be 0. That's going to be that's going to be a -m. That's going to be 0. That's going to be 3. So that's going to be a half. And that's going to be m-9/2. That's going to be a 1. And so then that's going to be 4, and that's going to be canceled, so that's going to be 0. And that's going to be times that, so it's going to be what, -42? Okay. All right. So P, so the max P was equal to a -42, but we wanted to minimize C. So that's the opposite of that. So that's going to be 42. And that's going to be when what? Well, x2 is equal to 6 and x1 equals 6. So I just did it, top to bottom, and they're both 6. So you could put x1, x2 is 6. So that's going to be what it is. So this is really our solution. Min of C is 42, x2 and x1. Because remember, we said that that was equal to a minus a min of C. And so the opposite of that would be a -42. And so then that's where we get that. And again, that comes back to if we have a minimization problem, we're just going to take the opposite of that, maximize it, and then we'll get the actual value. And so when we get done, that's going to be our solution. Okay. All right, so let's stop there.